Well, in this video we are going to continue practicing solving polynomial inequalities. This is our third video in the series, thus problem number 5. So if you haven't seen problem number 1 through 4, you should probably go back and watch the previous videos. Now our strategy will be to start by rewriting the inequality with 0 on one side. So with that in mind, I am going to add 7x to both sides. Alright, so far that gives me 6x squared plus 7x is greater than or equal to 3. But I also need to subtract 3 from both sides. So that gives me 6x squared plus 7x minus 3 is greater than or equal to 0. For the rest of the problem, I am going to refer to this version of the inequality. Now, in order to solve this inequality, I need to start by solving the related equation 6x squared plus 7x minus 3 equals 0. So finding the zeros of the function will give me the boundary points for my solution set. So these key values will be very important. So the first thing I would try to do is try to factor this. This is a quadratic trinomial, so I have options. If this doesn't turn out to factor, I can always use the quadratic formula, which sometimes you have to do. 6x squared can factor in two ways. It is either going to be 2x times 3x, or if this doesn't work out, I'll go back and do 6 times 1. Now, the 3 can only factor in one way. It's 1 times 3. Now, the order does matter. I will not put the 3 here because that would cause a GCF, a common factor. And if there's no common factor in the previous step, there should be no common factor inside the parentheses. So, I wouldn't put the 3 there, wasting my time. I will try the 3 here and the 1 here. Now, inner plus outer must equal the middle. Inner, I have 9x. Outer, I have 2x. So I'm trying to get a middle of positive 7. So if I have a positive 9 and a minus 2, that would make positive 7. So a positive 3 would give me the 9, and a negative 1 would give me the negative 2. Also, positive 3 times negative 1 is negative 3. So even that works out. So that means I have factored it correctly. To continue solving this, I need to set these factors equal to 0. So I'm going to set 2x plus 3 equal to 0, and I'm going to set 3x minus 1 equal to 0. So let's see. Subtracting 3 from both sides, 2x will equal negative 3. Dividing both sides by 2, x is equal to negative 3 over 2. Adding 1 to both sides, I have 3x is equal to 1. Dividing both sides by 3, I get x is equal to 1/3. So these are the zeros of the polynomial. So these will be my border points, my key values. So I'm going to plot these on the number line to the right. Okay, so here is my number line. And let's see, I have negative 3 over 2 and 1/3. So I'll just put negative 3 over 2 here, and I'll put 1/3 here. Now as a decimal, negative 3 over 2 is negative 1.5. And 1/3 is approximately 0.33. Alright, I'm rounding somewhat. Alright, that'll help you visualize the test values that we're going to need, because these values, these key values, these critical values, divide the number line into 3 intervals, like so. Now, I'm going to need to plot these points, these values, and I need to decide will they be open circles or closed circles. Well, since we want values that are greater than or equal to 0, we want to include values such as these where the function is equal to 0. So we'll show that by making them closed circles. Now we need to pick a test value in each interval to see what's going on. So we need a value that is less than 3/2, less than negative 1.5. For example, negative 2 would work, or I could have done negative 3 or negative 4 or whatever you want. Now I need a value that is between negative 3 over 2 and 1/3. Well, seeing as how this is negative and this is positive, 0 is in here somewhere. So I could check the value of the function at 0. And I need a value that is bigger than 1/3. So I could use 1 or 2 or 3. I think I'm going to go ahead and use 2 this time. Alright, I just need something bigger than 1/3. Now in each case, let's keep in mind, solutions will be values that cause the function to be greater than or equal to 0. So in each case, I'm going to ask myself, will the function now be greater than or equal to 0 at that x value? And I am going to use my calculator to help me out. So go ahead and enter the left side of the function, the left side of the inequality, into the table feature of your calculator. So we need 6x squared plus 7x minus 3. So that was 6x squared plus 7x minus 3. Go ahead and make sure your calculator is still in Ask X mode, because that'll be best for what we are doing. Okay, ignore this. Alright, we are checking the values negative 2, 0, and 2. Okay, so negative 2, 0, and 2. So I'm getting 7, negative 3, and 35. So 7, negative 3, and 35. Now, as we said, in each case we want to know, is the function going to be greater than or equal to 0? Alright, because that's what it takes to be a solution around here. Is 7 greater than or equal to 0? Well, yes, it is. 7 is greater than 0. That means negative 2 is a solution, which means every x value in this interval will be a solution. I will represent all those solutions with this ray. Is negative 3 greater than or equal to 0? No. Negative 3 is not greater than or equal to 0. No. That means 0 is not a solution. So none of the values in this interval will be solutions. So leave it empty. Is 35 greater than or equal to 0? Yes. Yes, it is greater than or equal. It's greater than 0. That means 2 is a solution, which means all of the values in this interval will be solutions. I will illustrate them using a ray in that interval. So these two intervals have the solutions that I need. So I will represent them in interval notation this way. This first interval goes from negative infinity to negative 3 over 2. Including negative 3 over 2. So use a bracket. This interval on the right goes from 1/3 to positive infinity, including 1/3. So use a bracket. When your solution set is in two pieces, you're going to use a union symbol to join them together. So this is your solution in interval notation. Alright, let's do one more problem. Number 6. As before, our strategy will be to get 0 on one side first. So I'm going to subtract 2x from both sides. Okay, so far that will give me 2x squared minus x is less than 5. Alright, this is like 1x minus 2x is negative 1x, so there you go. I still don't have 0, so I'm going to subtract 5 from both sides. So that will give me 2x squared minus x minus 5 is less than 0. So now that I have 0 on one side, this is the version of the inequality that I will use for the rest of the problem. So to solve this inequality, I need to start by solving the related equation 2x squared minus x minus 5 is equal to 0. Because these solutions will be the critical values or border values that I will use on my number line as I form my solution sets. So how do I solve this? Maybe it'll be factorable. Considering that this is quadratic, alright, is a quadratic trinomial, if it doesn't factor, I can always use the quadratic formula. 2x squared can only factor as 2x times x. 5 can only factor as 1 times 5. Alright, but if I don't like this, I will switch these around and put 5 and 1. Actually, it doesn't look like it's going to factor at all. Inner plus outer must equal middle. Inner I have 1x, outer I have 10x. There's no way I'm going to get negative 1x out of this no matter how I pick the signs. And even if I switch these around and put the 5 here and the 1 here, inner I have 5x, outer I have 2x. There's still no way that these can make negative 1. So this is not factorable. So I'm going to have to use the quadratic formula to solve this. So the quadratic formula. Bear in mind that A is 1 and B, I'm sorry, that's false. My coefficients are A, B, and C. So I meant to say that A is 2, B is negative 1 because of the negative sign there, so that's negative 1, and C is negative 5 because of that negative 5. That's my A, B, and C. Now with that in mind, the quadratic formula goes like this. Okay, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm really going to be just substituting these values into the quadratic formula. However, there is something we're supposed to do. The part underneath the radical is known as the discriminant. You should always calculate the discriminant first, separately from the rest of the problem. So I'm going to just put D for discriminant. So b squared minus 4ac. Okay, so here comes my b squared minus 4ac. B is negative 1, so I'm going to put negative 1 right there. In parentheses, please. And then my a is 2. And my c is negative 5. So my discriminant, I can easily do this really in my head, but many students will benefit from using the calculator, and I want to make sure your work is correct. So, you know, do what you got to do to get the correct answer, including typing this in if you need to. So if we did negative 1 squared minus 4 times 2 times negative 5. The discriminant is 41. Alright, 41. Now we can go ahead and do the rest of the problem. So x is equal to the opposite of b, so that means positive 1 plus or minus the square root of the discriminant, which is 41, all over 2a. Well, 2a, that's 2 times 2, so that's going to be 4. 41 is a prime number, so this cannot be simplified any further. Now, we need to get values that we can put on a number line, though. So I'm going to need some decimal approximations here. Okay, so I'm going to go ahead and separate this out. See the plus or minus? That means we really have two solutions here, one with a plus and one with a minus. So this means x equals 1 plus radical 41 over 4, or 1 minus radical 41 over 4. Alright, so let's use our calculator to help us get two decimals, one for each of these. Okay, let's see, 1 plus radical 41 over 4. Let's see if I can remember that. So fraction mode, 1 plus, let's see, the square root of 41 over 4. Okay, ignore that and just hit the toggle key to force a decimal. So let's go ahead and do two decimal places. So 1.85 approximately. Whoops. So this is approximately 1.85. Now let's do 1 minus radical 41 over 4. Okay, 1 minus the square root of 41 over 4. Ignore that, hit the toggle key, negative 1.35. Alright, so 1.85 or negative 1.35, approximately. So we will use these values as our border points. Okay, our critical values on the number line. Alright, so let's put them way up over here. So here comes the number line. And we've got these two critical values. We'll put one here and one here. So they need to be in order. So we'll put the negative 1 first. So negative 1.35. Alright, and we had positive 1.85. Okay, so we will plot these two critical values, but we have to decide, should these be open circles or closed circles on the number line? Well, solutions will be values that cause the function to be less than 0. Okay, strictly less than 0. These are the values where the function will equal 0. So that's no good. So we don't want to include these values. So we're going to leave them as open circles. Alright, nevertheless, even though these are not solutions, they do serve to divide the number line up into 3 intervals. So we will just need a test value in each interval. So we need a value in the first interval that is less than negative 1.35. So I could check the value of the function, for example, at negative 2, or I could have done negative 3 or negative 4. I need a value to check that is between negative 1.35 and positive 1.85. Between a negative and a positive number is 0. So I will use 0 as my test value. And I need a value that is greater than 1.85. So I'm going to use positive 2, or I could have used 3 or 4 or 10 or 100, whatever I wanted. Now, again, solutions will be values that cause the function to be less than 0. So in each case, I'm going to ask myself, is the function less than 0 here? Is it less than 0? So let's use the calculator to help us test these values. So what I mean is, go ahead and put the left side of the inequality into the table feature of your calculator. So let's see, this is 2x squared minus x minus 5. Okay. Leave your calculator in Ask X mode, or put it in Ask X mode if it's not already there. Now let's see, what values are we trying to test? We're going to test the function at -2 and 0 and 2. Now it just so happens that these are the same values I used for the last problem. But if they weren't, you would just type over them. But they're already here, so the value of the function at these x values will be 5, -5, and 1. So this will be 5, -5, and 1. And again, in each case, I'm asking myself, is this less than 0? Because that's what it takes to be a solution. Well, is 5 less than 0? No, silly. 5 is not less than 0. That's crazy. That means -2 is not a solution, which means there are no solutions in this interval. So leave it empty. Is -5 less than 0? Why, yes, of course, it is. That means 0 is a solution. So all of the values in this interval will be solutions. So I will illustrate all of the solutions with this segment. Is 1 less than 0? Oh no. 1 is not less than 0. That means 2 is not a solution, and none of the values in this interval will be solutions. So this middle interval is where all the solutions will be. So I will write this in interval notation in the following way. -1.35 to 1.85. I am using parentheses at the beginning and end of the interval for the same reason I used open circles, to show that the border points, -1.35 and 1.85, are not to be included. Again, those are values where the function equals 0, and we want to know where the function is less than 0. So you can't include the endpoints, thus parentheses. Anyway, this is the final answer in interval notation. Alright, that's going to do it for this video. I hope it was helpful, and I hope to see you on the next video.